Good morning, sir.
Just confirm whether I am audible clearly or not. I'm using a different system.
Yes, sir.
Good morning, sir.
Good morning, Priyas.
Good morning, sir.
Good morning, Tulka.
Good morning, sir.
Good morning. Okay. We will be doing some select problems of NCERT. A few I will be skipping.
Good
A few
morning,
we
sir.
have already done. Good morning. We have already done a few. Okay. So in that case, I will be skipping those ones. I have not included. The very first question of NCERT. Why it is tricky one? Because in many books you will see, okay, I'm specifically saying guides. This question has been answered differently, and because your teachers consult a specific guide, sometimes your correct answer they will mark as wrong. So there are two ways. Okay. One is that you need to tell them that this is how it is correct, which I will be explaining. And the other way is that you talk to your teacher, and then whatever he says in 11th, your teacher is your God. Okay? So whatever he or she says, do that. Okay. Okay, Ariman. So these are two ways, but I will suggest every student will speak to teacher that what should be the answer, just in a way that you will say, I think this is the answer, sir. Is this correct? Or ma'am, is this correct? Whatever she tells you or he tells you, write that. But I will be telling you the correct answer. A liquid is in equilibrium with its vapor in a sealed container. Container is sealed. Sayed, good morning. At a fixed temperature, the volume of the container is suddenly increased. If you understand it with diagram, you will yourself get the answer. You don't need to see those guides where answers are not correct. Okay, okay, Aniruddha, fine, fine. Okay, everyone keep your videos switched on. As I have already mentioned, I have received information about you, those who are traveling. Except those, everyone will keep video on. I have allowed them to continue the class considering the situation. Only few students. What is the initial effect of the change on vapor pressure? So what is vapor pressure? Vapor pressure is, suppose this is water here, liquid, and it will start evaporating here. This is sealed container. When there will be some pressure build up here, some pressure. What will happen due to that pressure? The gaseous molecules, means the H2O gaseous, will get condensed. So there will be two processes, evaporation and the other one, condensation. You know what is evaporation, what is condensation. Okay, okay, Bhavya, fine, noted. Fine. Now what will happen after some time? Here the pressure will be sufficiently high. When I say sufficiently high means now at that stage, evaporation and condensation rates will be same, and that will be equilibrium state. At equilibrium, whatever is this pressure, that is known as vapor pressure. So first you need to understand what is vapor pressure. Vapor pressure is that equilibrium pressure when the rate of evaporation and rate of condensation is same. Now question is, you increase the volume, volume is increased suddenly. So suppose now the volume is this. So what will happen? You still have water here. Okay. Now because here the volume has increased, the pressure will decrease. Okay. The pressure will decrease. Is there any confusion to understand this one? Because volume has increased, there are still same molecules, same number of gaseous molecules here. They will not create that much pressure now. Fewer molecules now will be striking the walls. Fewer molecules striking the walls. It means per unit area. So it means there will be less pressure. So initially the vapor pressure here will decrease. In guide it is written increase. Okay, few guides. However, I found that on internet it is correct. Correct answer. Okay, it will decrease. So first answer is it will decrease vapor pressure. Then how do rates of evaporation and condensation change initially? This is again different answers are there on that. First A part is clear everyone. Any confusion? Let me know. So volume increased, pressure decreased, so vapor pressure will decrease. B part is how do rates of evaporation and condensation change initially? Initially we are talking about, obviously C part is at equilibrium again, but here we are talking about initially. Initially what will happen, because here the pressure was, say pressure became here vapor pressure, say it is 180. Okay? Say it is 180 vapor pressure, just for ease of it. When you increase the volume, liquid is same and vapor pressure will initially decrease because it is closed container, it is not open. 0.5 atm say. Now if it is 0.5 atm, means there is less pressure on the surface of the liquid. This 1 atm will create greater pressure on the surface. This 0.5 atm will create less pressure on the surface. Now as per Henry's law, if this pressure above the liquid is less, there will be less gas dissolved here. Means less H2O gas here. Initially what should happen? Initially it will try to evaporate more because there is less pressure from the outside. So evaporation will actually increase initially, which in many books it is written it will remain constant because temperature has not changed. Remember, apart from temperature, evaporation also depends on pressure. Okay, because it is closed container, that's why it will depend on pressure. Any confusion here? If there is less pressure from top, more molecules will get converted into gaseous phase. So initially evaporation will increase, but condensation will decrease because there is less pressure here. Now, because this is less pressure, it will not force the molecules inside the water liquid with the same force as in this case. So in this case, the force is greater pressure, greater force. So condensation will be higher here. Here will be less condensation. So in this case, evaporation will increase even though the temperature is same, condensation will decrease. But you will talk to your ma'am or sir because they will follow different guides or maybe internet. Then the next one, C part. What happens when equilibrium is restored finally and what will be the final vapor pressure? When equilibrium is restored, then again, it will have the same vapor pressure. So no change in the vapor pressure. It will attain the same vapor pressure. As I told you, if it is equilibrium, another equilibrium, then same vapor pressure will be no change. So final vapor pressure will be same because temperature has not changed. In this case, yes, you will say because temperature has not changed and it has attained equilibrium again. So both the conditions met, equilibrium and fixed temperature. So vapor pressure will be same as initial. If there is no confusion, then I will move to next question. At a certain temperature and total pressure of 10 to the power 5 pascals, iodine vapor contains 40% by volume of iodine atoms. This is the reaction given. Calculate K. Now, why this is important? Okay. Because here students are not able to understand what is this 40% by volume. How do we solve this? Any idea? Anyone? What do you understand by 40%? Iodine vapor contains 40% by volume of iodine atoms. What do you understand by it?
So like in 1 liter, 40%.
Come again?
Sir, 1 liter volume, 40% of iodine.
Okay. Okay. So do you remember I talked about that the pressure is proportional to number of moles? Remember one of the classes we talked about it, PV equals to nRT. And if I write P equals to nRT by V, this volume is constant, R is constant, T is constant, means pressure is proportional to number of moles or number of molecules. Number of molecules. It means if I am talking about 40% by volume of iodine atoms, I am talking about here this much percent of molecules. If this is the molecules, because volume and molecules are proportional, you know, right? 22.4 liters will have 6.022 into 10 to the power 23 molecules. Is that clear, everyone, or not? Any confusion? Just ask. These type of questions will create problem for you if you don't understand this concept. 40% by volume means I am saying 40% molecules because volume is exactly directly proportional to the number of molecules. Clear or not? At constant pressure. So it means I can say pressure by these 40% will be 40% of total pressure. So pressure by iodine atoms, remember iodine atoms are here. So question says that you have 40% iodine atoms. Okay, it means 60% you have iodine gas, and the pressure will be exactly in this proportion because pressure is proportional to number of molecules and 40% volume means 40% molecule. 40% volume means 40% molecules. Anyone not clear about it? Sayak, clear or not?
Yes, sir.
Bhavya, clear or not?
Yes, sir.
So it means I can say pressure of iodine atoms will be equal to 40% of total pressure. Means it will be 40 by 100 into 10 to the power 5 Pascal. Total pressure is given. Means it will be 0.4 into 10 to the power 5. And partial pressure of iodine gas will be 60% of it. Okay, or you can say rest of the pressure will be by iodine. So that will be 0.6 into 10 to the power 5. Obviously 60% you can write pascals because it is given in pascals. Now the moment you get the partial pressures, you can get Kp, sorry. Kp for this reaction will be what? It will be iodine's partial pressure raised to stoichiometric coefficient divided by iodine atoms here, iodine atoms. And then here iodine gas partial pressure raised to the power 1, that is 1. So substitute these values. 0.4 into 10 to the power 5 whole square divided by 0.6 into 10 to the power 5. So 10 to the power 5, 10 to the power 5 will 1, 10 to the power 5 will get cancelled. And 4 by 6 will be 2 by 3. 2 by 3 will be 2 by 3 will be 0.667 into 10 to the power 5. 1 10 to the power 5 will get cancelled. Sorry, it will be 0.267 by 3. Yes, correct. No, I'm writing it. It will be whole square here. Whole square. So 16 by 6 I will have to calculate. Okay. Sorry. 16 by 6, 16 the 12, 4, 16. Right. 0.0 here. 6, 6. Okay. It is 2.67, rather 0.267 into 10 to the power 5. That is 2.67 into 10 to the power 4. And the unit will be here. If you want to write, here it will be Pascal square. Here it will be Pascal. It means unit will be Pascal. Any confusion here? Anyone? If there is no confusion, I will move forward. So make sure that you understand all the points. Okay. So it is 2.67 into 10 power 4 pascals. Next, write the expression for the equilibrium constant Kc for this particular reaction. Okay. So for this reaction, this is solid. You will not consider it. That's the only thing you need to keep in mind. So it will be Kc equals to 1 because product side don't need to consider anything. It is pure solid. And here it will be Fe3 plus. There is only 1 mole, so you don't need to write anything. OH minus, there are 3 moles, so to the power 3. That is the answer. For this one, this is a solid, pure solid, you will not consider. And if it is not given, you should know these are gaseous. Okay. Chlorine is a gas. Iodine pentafluoride is a gas. Moreover, in cases if it is not written, you will consider. So the thumb rule is if there is S or L written, then you will ignore it. Otherwise, if it is written gaseous, you will consider. If it is written aqueous, you will consider. If it is not written, then also you will consider. You will consider both of these. Kc will be product concentration, that is IF5 raised to its stoichiometric coefficient 2 divided by reactant concentration raised to its stoichiometric coefficient 5. Will not consider this one. Sorry. Find out the value of Kc for the following equation. Kc will be, Kp is given. Okay, Kp is given. So you will write Kp equals Kc RT to the power delta Ng. Substitute the values. Okay. Depending on what value you take of R, the unit of Kc will be there. Okay. So Kp is given 167 equals to Kc RT 8.314. I am taking it in Joule. It is given 1073. If it is not given, you will take 298. 1073. What will be delta Ng? Delta Ng will be gaseous moles of products, that is 1, minus gaseous moles of reactants, you have 0. So it is 1. Okay. You will not consider solids, liquids, only gaseous moles. Only. Okay. Here even aqueous will not be considered, only gaseous. So Kc will be 167 divided by 8.314 into 1073. Depending on your value of R, the unit of Kc change. So that is something you must remember. There should not be any confusion here in this case. Any confusion here? Obviously, you will have to solve it. Anyone? I will move forward if you say there is no confusion. Remember. Okay. So here, right. Here it is given 1.87. It means we have considered 0.0821. Okay. That's why. Question number 4, Srishti. Question number 4 is this one or previous one? Any confusion you need to ask, right? Now this answer, I would suggest this one, right? Because this is probably answer given in NCERT. So that's why probably I have written it here. In that case, you should consider it as standard one. And what is a standard? Standard, whenever I say standard, it is bar. Sometimes you can take as ATM also. So 0.083.
Sir,
Yes.
so unit.
Unit in this case, because here Kp unit is not given, it is unitless. It is temperature, that is Kelvin. It is bar, so it will be bar inverse Kelvin inverse. You will decide the unit on the basis of the formula.
Okay, sir.
Sir,
Yes.
sir, generally we use this 0.083.
Normally standard form is bar, and if it is bar, use 0.0831. For calculation, I would suggest that don't use one. Even if you write, suppose 1 here, when you do calculation, don't consider this one. Yes, for standard we use bar, and in bar it is 0.08. So when you solve now this one, you will get 1.87 approximately. Next one. Explain why pure liquids and solids can be ignored while writing the equilibrium constant expression. This is something you remember. I told you that we should not be using the pure liquids and pure solids concentration because their concentration remains constant. And what I explained diagrammatically, that if you have this much amount and you have some concentration or maybe some density, density is also unit of concentration. So if you have say 10 grams per milliliter, so if you consider this part, suppose this part remains after reaction, this gets consumed after reaction, you have this one, this will again have 10 grams per ml, same concentration, same density. So that's why you can merge this concentration into equilibrium constant itself. But how will you write it? There is something formula and you will show it. This is how you will show it. Say concentration is number of moles of solute divided by volume of solution in liters. That is molarity. Okay. And you need to find a way to show that the values on which this depends, they do not change. So you will say it is equal to mass divided by molar mass, number of moles, mass given mass divided by molar mass. Then you can rearrange this. So it is mass divided by molar mass and then volume in liters. So same thing, I have just rearranged it. Now you can club these two, mass over volume, this one. So mass over volume is density, you know. So for this one, you have written density. Density divided by molar mass. And you know, I have told you density does not change. Whether you have this much amount initially or you have this much amount finally. Density is constant of a substance if it is pure. Molar mass is also constant for a particular compound. So the entity here, both of the things are constant. So it means the concentration does not change. It can be merged with equilibrium constant itself. So as density of a pure liquid or pure solid is constant at a constant temperature and molecular mass is also constant, therefore their molecular concentration or molar concentration remain constant. This last statement you must write. Your teacher actually doesn't go through all what you have done here. He just or she just looks onto the concluding line. That is correct, you get the marks. To understand the importance of last concluding line. Normally toppers always include concluding line in the numericals or wherever you have.
Sir,
Next
can you
question.
take your previous slide? Thank you, sir.
Reaction between nitrogen
Sir,
and
a little
oxygen.
bit was left.
Huh?
Sir, I had a little bit left to right.
Okay.
Okay, done, sir.
So this is the reaction. Nitrogen reacts with oxygen to produce N2O. If a mixture of 0.482 moles and 2.93 moles of O2 is placed in 10-liter reaction vessel and allowed to form N2O at a temperature for which Kc is AC is given, initial concentrations are also given. Determine the composition of equilibrium mixture. So first you need to understand what is asked. Concentration of nitrogen, oxygen, and N2. These have been asked. So you will do your favorite method. You will write the reaction. 2N2 plus O2 gives you 2N2. I'm not writing gaseous, all are gaseous. I don't need to bother about that. I will write initial concentrations. Initially, I have 0.482 moles of nitrogen. I have 0.933 moles of oxygen. And there is nothing else. We start with that. But here, the vessel is not of 1 liter. It is of 10 liter. So it means these are not the concentrations. These are just moles. You have to divide the moles by volume, get molarity. Number of moles divided by volume of the solution in liters is molarity. Now this is the concentration. Is that clear, everyone, or not? Or if there is any problem to understand it, you will ask. Even if I don't say you need, is that clear or not? If it is not clear, you will ask. Okay. And this was the initially. And equilibrium, at equilibrium Kc is given. So you will say, okay, suppose X moles got consumed. So I'm now writing it as 0.0482. Just have some more space. 0.0482. I'm just at some other place at the moment, so my connection might be slightly slow, or you might be experiencing some lag when I'm writing. Bear with it. So what will happen? What is the change? Suppose change might be here minus 2x. Why I'm saying minus 2x? Because it is 2. So 2 will be consumed. This will be, one part will be consumed, so it will be minus x. Now tell me how many parts will be produced?
Sir, 3x.
No, Rohan. 2 parts nitrogen consumed, 1 part oxygen consumed, as per 2:1 ratio. Ratio is 2:1. So tell me, how many parts of N2O will be created? Mahi, good, correct. How many parts? It is 2 here. This 2 is to 1 is to 2. The ratio is 2:1 is to 2. Okay. Here is 1, which is not written, and 2. It means if you have 2 here, you will have 1 here, you will have. The only difference will be here it will be positive because it is being produced. Is that clear or not, everyone? Yeah, yes. Now, is there any confusion? Okay. So understand it. How I get these values? It is always in molar ratio. And molar ratio here is 2:1 is to 2. So if you want to write something, you will write first 1. That is the molar ratio. Here, then you will write x. 1x means x, and then x. And then on reactant side, you will have minus. So this is the way also to get the change. What will be the change during the reaction? So at equilibrium, what will be the case? At equilibrium now, you will have 0.0482 minus 2x. Here you will have 0.0933. Earlier you had and X got consumed. Here earlier you didn't have anything, now you have 2X, so it will be 2X. Any problem? Anirudh, any problem? Hmm? Are you there, Anirudh? Right. And there is, yes, Ishita, clear or not?
Yes, sir.
Srishti?
Yes, sir.
Okay. So tell me, Srishti, what is X here? What is X? Whatever comes in your mind, just tell me.
That alpha.
Yes, Rohan, correct. Okay. But you need to mention of oxygen. Okay. No, it is not degree of dissociation. Degree of dissociation will be C alpha. Okay. This whole is X means it is C alpha. Degree of dissociation is only alpha. X is the amount of oxygen consumed during the reaction. X is amount of oxygen consumed during the reaction. Hence, 2x will be amount of nitrogen consumed and 2x will be amount of N2O produced. That's how you will write it. So now if you know the concentrations, equilibrium concentrations, can you tell me, can you get X or not? And how do you get X? Will tell me. Equilibrium concentrations are here. Now how will you get the value of X?
Sir, product concentration by reactants concentration equating to Kc.
Basically, you need to say that I will substitute these values in equilibrium constant formula, right? Because equilibrium constant is given. So here you will write Kc for this reaction. For this reaction, Kc will be N2O whole square divided by N2 whole square and O2. All are gaseous. Substitute these values. N2O produced is 2x whole square divided by N2. N2 is this much, 0.0482 whole square. O2 is this much, 0.0933 minus x. Equated to Kc, Kc is given 2 into 10 to the power minus 37. So you need to solve it. Okay, I'm not solving it. It will consume a lot of time. You have to do all these questions, okay, and submit on the website in few days. Any confusion you can ask. Okay. Tulika, in question number 7, I will get back after this question what you are trying to say. I don't get what you have written, but after this question, I will try to understand. So once you get the value of x, after that, you will substitute that value of x here, and you will get the equilibrium concentrations that is asked, composition of equilibrium mixture. Any confusion here? Obviously, you will get quadratic equation. You will have to use minus b plus minus square root b square minus 4ac divided by 2a, and you will select the positive value only.
Excuse me, sir.
Yes.
सर वो नीचे डिनोमिनेटर में 2x भी आएगा ना साथ में?
डिनोमिनेटर में 2x क्यों आएगा? You have nitrogen
Sir,
concentration whole square, oxygen concentration whole square. Okay, you are saying here This one,
Yes,
this one,
sir.
right? So this has to be written basically here. This one, right? 0.0482 minus 2x. So once you get the values, we'll substitute those values here in all these three. Okay, now I'm going back to question number 7. Yes, tell me, what was your question? Tulika.
Sir, in the solute can be gases also. So, sir, why this formula is not applicable for gases?
Because if you change the volume, gases will expand. They will occupy the volume, whatever volume is there. But liquid and solid will not expand. Their density will not change. You're getting it what I'm saying? Suppose you have this container, this much container, and after reaction also this will be the container. Suppose you had 2 moles here initially, and after the reaction there is 1 mole. You can't say in case of gases that gas will remain only here. Gas will occupy this space also. Are you getting me or not?
Yes, sir.
So volume will change. If volume will change, the concentration will change. Here it is 2 moles in say 4 liters. It will be 2 divided by 4. Concentration, molarity will be 2 by 4. But here it is 1 by 4. Are you getting me? Why? But if it is liquid, then liquid will only stay here. So its concentration will remain same. It will be 1 by 2 because volume will also decrease. Any confusion, Tulika?
No, sir, it's clear now.
Okay. When you solve, you will get these values. Now, the next question. Nitric oxide reacts with bromine to give you nitrosyl bromide. When you have NO this much, Br2 this much, these are mixed in a closed container at constant temperature. These many moles of NOB are obtained at equilibrium. Calculate equilibrium amount of NO and Br2. This type of question we have done in case of HCl. If you remember that 30 moles of HCl, 30 ml of HCl produced from there, we got 2x is 30, x is 15, if you remember, if you can recall that question. So we will do the same thing here. We will write 2NO plus Br2 gives you 2NOBr. Initially you have 0.087 moles of NO and 0.0437 moles of Br2. And obviously you have 0 moles of NOBr, nitrosyl bromide. Now what you can do? At say what is the change? Okay, some change will take place. So if some change takes place, first you need to tell me what you need to consider. What you need to consider here. Read the question before I start the explanation. What you need to calculate? Okay, calculate equilibrium amount of N and Br. And remember, equilibrium constant is not given. That's why I am asking. We have done similar question. That's why you should be able to tell me the answer. If you have understood that question, HCl produced, H2 plus Cl2 gives you 2 HCl. That question, if you can recall, you can tell me the answer. No? Anyone? It's not that tough. Okay. Now at equilibrium, suppose here it is 1 mole. So suppose X got consumed. 0.0437 minus x. So here, if x got consumed, I will write the change as minus x. Here we have 2 moles, it will be minus 2x. But here is the information. You have 0.0518 moles produced, okay, at equilibrium. So you will write here in terms of production 2x. And this 2x will obviously be equal to 0.0518 because at equilibrium now, what will be the amount here? 0.087 minus 2x, 0.0437 minus x, and 2x. These will be equilibrium amounts. And this 2x is given 0.0518 at equilibrium. So from here, you got the value of x as 0.0518 divided by 2. Any confusion here? Okay. So once you got this value will be 0.0259, then 10, and then 9. Correct. Okay. So substitute those values here. When you substitute these values here, you will get the concentration of NO and PR. Okay. Now here it is written equilibrium amount, and you should be specifically concerned here because volume is not given. So you can't say these are concentrations. You can say these are the amounts, means these are the number of moles. So understand it very clearly. In these type of questions where volume is not given, you cannot say these many moles are actually concentrations because you have to divide it by volume. So you will do calculation in terms of moles only. You will say, okay, I have these many moles. I have these many moles. And it is 2 is to 1 is to 2. It means here 2 parts will get consumed, here 1 part will get consumed, and here 2 parts will be produced. Again, in terms of moles, not in terms of concentration. These parts will also be in terms of moles. Here also you have moles only, okay? Moles. So the value of x will be actually mole. And here also you will get mole and mole, not the molarity. That's why amount is written, not concentration, not composition. Amount is in moles. Any confusion? Okay. When you calculate, this is the answer you will get. Next. I think this is very easy. Why I have been here? Okay, Kp is given. You need to calculate Kc. It is very easy one. So Kp is equal to Kc RT to the power delta Ng. Kc will be Kp divided by RT to the power delta Ng. Kp is 2 into 10 to the power 10. And it is per bar. Obviously, it has to be per bar because here it will be partial pressure square. Here it will be in the denominator, it will be partial pressure cube square and 1. Obviously, denominator will have 1 extra unit. So per bar. And RT, because it is given in bar, you will use value of R as 0.083. And T, temperature is not given, you will use 298. What will be delta Ng? 2 minus 3. Here you have on left hand side 3, on right hand side 2. 2 minus 3 is minus 1. Anything not clear? Okay, everyone. If there is any problem, you need to ask. Yeah? I will move to next question. When you solve, obviously, you will get answer 7.48 into 10 power 11. Because 10 power 10 you already have. And because this is minus 1, obviously, this will go into the numerator as multiplication. So that's why it will be 10 to the power 11 in the answer. Any confusion, just ask.
No, sir.
Now moving to next question. This one. A sample of hydrogen iodide is placed in flask at pressure of 0.2 atm at equilibrium. The partial pressure of HI is this much. What is Kp for the given equilibrium? Easy one, right? Now, before I move forward, 2 minutes back, I had written on the screen to mark the presence. I will consider only till Paranith, not after that. So in reverse order, the attendance was marked by Paranith, Srishti, Vanshika, Tulika, Bhavya, Ishita, Shurtant, Rida, Rohan only. Only these 9 students marked presence, and at the time 19 are connected. Okay. So less than 50% marked their presence. Others can specify why didn't you mark the presence? I have noted down these names, those who mark the presence. No, Swayam, I won't consider your presence now. Sayak, I won't consider your presence now. Okay. Only till Paranith I will consider. I spent more than 1 minute on that screen, highlighted that you need to mark your presence, but you didn't do that. But on this part, I will speak to you later on. Now moving to next question. A sample of HI. This is the reaction here. Sayak, I will talk about it later on. This is the reaction. And partial pressure of HI is 0.4 atm at equilibrium. Initially, it was 0.2 atm. So sample of HI is placed in a flask at a pressure of 0.2, means this is the initial condition. So you will say, okay, initially I had 0.2 atm. You can talk in terms of pressure. Okay, here 0, here 0. Then say whatever is the change, say minus P, you will say 2. Otherwise, if you say minus P here, because the ratio is 2 is to 1 is to 1, you will have to consider half here. You will have to write here P by 2. Sorry, plus P by 2, which doesn't make any sense to do calculations in fractions. So what you will say? You will say 2x consumed or 2p consumed, because here we are talking about in terms of pressure. I'm writing. Then it is 2 is to 1. On right hand side, it means P will be produced, P will be produced. It is also 1. Then it is written at equilibrium, the partial pressure of HI is this much. It means this minus 2p is given 0.0. Clear? So if it is given, you can calculate Kp. Just tell me the answer. I need answer of this one. Can do it. Tell me the answer of this. It is easy. I'm saying that this is actually 2p. Because, no, sorry, this is not 2p. It is at equilibrium. This will be 0.2 minus 2p. This will be p. This will be p. This is given as 0.04, not 2. 0.2 minus 2. So from here, you need to get the value of P. The moment you got P, you know the partial pressure of iodine and hydrogen also. I'm talking about the answer. Okay, what is Kp? Tell me Kp. So if you have 0.2 minus 2p equals to 0.04. So from here you can calculate P. Okay. So P will be 0.2 minus 0.04. That is 2P will be 0.16. That's P will be 0.08. And it is given in ATM, you will say ATM. So it means now you have the partial pressure of hydrogen, partial pressure of iodine, and also partial pressure of hydrogen iodide. Okay. So when you calculate now, substitute the values. This is anyway you have calculated 0.08, 0.08. This will be 0.2 HI, 0.2 minus 2 into 0.08, 0.16 is 0.04. When you solve it, it will be 0.04. Substitute these values to get Kp. Kp will be partial pressure of hydrogen multiplied with partial pressure of iodine, product's partial pressure raised to its stoichiometric coefficient divided by partial pressure of reactant raised to their stoichiometric coefficient. Substitute these values, what we have calculated, get the answer. Okay. So let me check who has given the correct answer. Bhavya, Mahi, Priyas, correct answers. Ashmai, decimal not correct. Sayak, Veda, correct. Tulika, correct. So when you substitute these values, 0.08 into 0.08 into 0.04 whole square means it will be 0.04 into 0.04. So you can have 2 times 2 into 2, 4. The answer will be 4. Next, a mixture of 1.57 mole of nitrogen, 1.92 mole of hydrogen, ammonia into 20 liter. Now here volume is given. You can calculate the molarity, that is concentration. Concentration can be calculated from here. Temperature is also given if we want to use. At this temperature, the equilibrium constant Kc is also given. Reaction is also given. Nitrogen, hydrogen gives you ammonia. Kc is given. Is the reaction mixture at equilibrium or not? And you know how to do. You know what is Kc? Kc is given. Calculate Qc with this information given. Calculate concentration, number of moles divided by volume. Number of moles divided by volume. Number of moles divided by volume. So you can calculate the concentration at any point of time. Calculate Qc, compare it with Kc. That's how you will get the answer. Any problem here? I don't think in this case there should be any problem or I should be wasting time here. What I am saying, nitrogen concentration, you will first write at non-equilibrium point. Concentration of N2 is number of moles divided by volume. Concentration of H2, number of moles divided by volume. Concentration of NH3, number of moles divided by volume. Okay, this is what you got. So you can calculate Qc. C will be product's concentration raised to its stoichiometric coefficient divided by reactant's concentration raised to their stoichiometric coefficient. Substitute these values, get the value of Qc, and compare it with Kc. See whether I have the answer or not, whether QC will come out. QC will come out to be when you solve 2.4 into 10 to the power 3. And obviously it is greater than Kc. Kc is 1.7. So it means reaction will go in reverse direction. Yes, Ariman, concentrations, I would suggest don't simplify here. Okay, leave these as they are. Because 2020 will get cancelled. Okay, quite a few 20 will get cancelled. Otherwise, you will have to do one extra step. Multiplication is always easier than division. So don't do division first. So any confusion here? In all such cases, you will calculate QC, compare it with Kc, get the answer. Next, the equilibrium constant expression for a gas is this one. Write the balance. Now this is reverse. Okay, so what is Kc? Kc is product concentration raised to their stoichiometric coefficient. So it means the reaction would have been ammonia. How many ammonia? Moles 4. And oxygen 5. Reactants here 4. Nitric oxide and 6. And remember, gaseous, you will consider here not pure liquids. So means this is gas and you will not write it as liquid because it is written here. It means it must be there in gaseous form. This will be the answer, reverse of that. Yes, Ariman, correct. So the powers will go to the stoichiometric coefficient. These are stoichiometric coefficient. And remember, on top we have product, denominator, reactants. Next, 1 mole of H2 and 1 mole of CO are taken in 10-liter vessel and heated to 725 Kelvin. At equilibrium, 40% of water by mass reacts with carbon monoxide according to this equation. Calculate the equilibrium constant for the reaction. Anything not clear here? First, I am talking about question only. Okay. See, I will explain it. First, I am asking if anything not clear about the question. Okay. So first, you need to understand what we mean by at equilibrium 40% of water by mass reacts with carbon monoxide according to this. What it means 40% by mass. Remember, if it is 40% by mass, it will be 40% by moles also, because moles are directly proportional to mass. Kashmir, that's what I am explaining. I know students face problem there. That's why I asked that question. Okay. So whenever it is written 40%, we need to understand whether we are talking about in terms of volume or mass. They will always be related to moles. Volume is directly proportional to moles. Mass is also directly proportional to. Why? If I am talking about only one compound. Why? Because number of moles is given by mass divided by molar mass. So for a particular compound, here I am talking about water. Moles are proportional to mass because this molar mass is 18, it is constant. Okay. So it means if I talk about the number of moles of water, those will be 40% of 1 mole. These react 40% water reacts. It means 40% of 1 mole will react. Try to understand. If you are not getting it, ask again. Here it is written that 40% got consumed, 40% by mass. And if it is 40% by mass, it will be 40% by moles also. I explained it why, because molar mass is constant. And you initially had 1 mole. Initially, writing the normal pattern, what we do, initially we have 1 mole of H2O and 1 mole of carbon monoxide in 1 liter vessel. So first I am trying to get number of moles. Obviously, after that I will get the concentration because here it is in 10 liter. So How much is the change? Change is minus 40%. It is given minus 40. Minus 40% means 0.4 moles got consumed. If 0.4 moles got consumed of water, same moles will get consumed of carbon monoxide also, because it is 1:1 ratio. Anything not clear? Okay. Now the question is, calculate the equilibrium constant for the reaction. So here also it will be minus 0.4. And because here also it is 1:1 ratio, it means here 0.4 and 0.4 moles will be produced. Is that clear or not, everyone? So we are doing exactly same thing what we have been doing. The only thing is, first we had to convert this 40% to moles. That's it, nothing else. It means at equilibrium, what will be the case? At equilibrium, we had 1 mole of H2O, 0.4 consumed, 0.6. Here also 1 mole, 1 minus 0.4, 0.6. Here we had 0, 0 and 0.4, 0.4 produced. This is the equilibrium concentration, but sorry, equilibrium composition in terms of moles, not concentration. Now you will divide it by 10 because here volume is given. This is the volume here. Okay. So you will say concentrations, these are moles. Concentration will be 0.6 divided by 10. I'm not writing, you should write, okay? Here, concentration. Concentration. 0.6 divided by 10, 0.4 divided by 10, 0.4 divided by 10. Now you will substitute these values, you will get the equilibrium constant. Calculate equilibrium constant. Equilibrium constant will be products concentration, gaseous ones, okay. Sorry, non-liquid, non-solid ones, H2CO2 divided by H2O and CO. All powers are 1, so I'm not writing. So it will be 10, 10, 10 will get cancelled anyway, right? So it will be 0.04 into 0.04. I'm writing 0.04 because if you divide it by 10, it is 0.04. And 0.6 divided by 10, 0.06. So it will be 4, 4, 16 divided by 36. Nine 4s are 36, 4s are 4s are okay. So it will continue 0.44. Yes, Priyas, correct answer. Yes, Ariman, that's fine. No student should be facing problems. If there is any problem, you need to ask right now. Okay. Ask right now that this particular step is not clear. Okay. Next question. At 700 Kelvin, reaction is given and Kc is given. Equilibrium constant is given. Okay. 54.8. If 0.5 mole per liter of HI is present at equilibrium, what are the concentration of H2 and I2, assuming that we initially started with HI? Now there is a tricky question where students make a mistake. They start with this particular reaction. However, question is talking about reverse reaction. You are starting with HI. So the first step you will do, and it is not done in guides like that, you will follow this approach what I am telling. Otherwise there is confusion if you follow different approach. You will first change it, right? You know that if you write it as 2HI, gives you H2 plus I2. The only difference will be that K here will be 1 by 54.8. Instead of 54.8, it will be reciprocal of that. Okay. 1 by 54.8. So you will first change this one. And now the question is very easy. Okay. Now the question is that at equilibrium, you have these many moles of HI present. Now my question is, how many moles did you start with? It is not given here. How many moles you started? How will you solve this question? This is the only difference now. There are two important points about this question. Okay, note down question number 15. I always suggest to do this question after the class also. Okay, do it 2 times so that you can understand how tricky the questions can be. There are 2 important points. First, I changed it. I reversed it. And I said K is 1 by 54.8. Now my question is, till now, we have done all the questions where we had some initial amount of HI. We started with that. Here, nothing is given up. It is written just at equilibrium, I have 0.5 moles of moles per liter concentration of HI. How will you do that? Anyone? When you start doing it, you will get the answer yourself. Okay. So suppose you don't consider anything, just consider equilibrium. At equilibrium, it is given you have 0.5 moles per liter. That is the concentration. You will assume that, okay, this is X. Why? Those will be X because there is 1:1 ratio. So if hydrogen concentration at equilibrium is X, iodine concentration has to be X because the reaction has started from HI side. So initially, obviously, these were 0. No amounts were there of hydrogen and iodine, and exactly same amounts will be produced because their ratio is 1:2. So you will assume in this case that assuming hydrogen and iodine concentrations at equilibrium are X each. X each. Okay, you don't know what is the concentration. Now you can easily apply it in the formula of Kc. Now you can say for this reaction, Kc is equal to hydrogen ion concentration, iodine concentration divided by hydrogen ion concentration whole square, which is obviously 1 by 54.8 from here. Substitute these values now. You will say X into X divided by 0.5 is 1 by 54.8. It will be whole square here, right? Whole square. 1 by 54.8. You get the answer. You get the value of X. You get the answer. Concentration of H2 and I2 will be X. I hope everyone is clear about it. So when you solve, you will get the answer as 0.068 mole per liter. So this will give you X as 0.068 mole per liter, which will be concentration of both hydrogen and iodine. Ashma, yes, temperature will make difference, but it is written it is 700 K initially also and finally also. So there won't be an impact. At a constant temperature, the value remain constant. We can't say if temperature changes, we can't say what will be the value unless we have been given some other values. We can't say, suppose question you, if you are saying that what will be the value at 600K, we don't. There should be some supportive information available. Otherwise, can't. Okay, now I will be, having 1 hour more class. Okay, but before that, I will be having 10 minutes gap. Okay? So 10 minutes break will be there. What is the time? Let me see. It is exactly 12:10. You need to be back at 12:20 exactly. Okay? No, Tolika, we can't equate 2x equals 2.5. There is no need for there. You can't do that because it is not from H2 and I2. Okay, so I will explain that when we rejoin why you can't do that. So I have 10 minutes break now. Stay connected, don't disconnect. Just be back at 12:20. Fine. I hope everyone is back. Not everyone.
Yes, sir.
Right. So the next question.
सर
What is the, yes.
सर एक बार क्वेश्चन नंबर 15 वो फ्लैश कार्ड वाले ग्रुप में डाल देना सर.
Question number 15. Okay, fine. What is the equilibrium concentration of each of the, before that, Tulika asked, Tulika, are you there?
Yes, sir.
Okay. Your question here was that why we can't write 0.5 equals to 2x. Okay. So if suppose we say it is 2x, why we can't say? Initially, there can be any amount. You can have, suppose 10 moles initially. Okay. And here would have been 0, 0 initially. Then at equilibrium, in that case, it would have been 10 minus something. Okay. That is 2x, sorry. 2x, which will be give you x and x because it is 2 is to 1 is to 1. So here if 2x is consumed, then x and x will be produced. This 10 minus 2x is 0.5 according to the question. And this can be 10 minus 2x depending on how many moles you had initially. And initially, if you had only 5 moles, it will be 5 minus 2x. So you can't say it is 2x. It is actually initial moles minus 2x. Did you get it? What I am saying?
Yes, sir.
So it is not being produced, it is being consumed. So it will be initial amount minus. Next one. What is the equilibrium concentration of each of the substances in the equilibrium when the initial concentration of ICl was 0.78 m? This one is easy question. I have just included here just for practice. Okay. Now initial. Okay. Initial concentration here is 0.78 and this would be 0 and 0. Now what will be the change? It is 2 is to 1 is to 1. Okay. So it means if 2x consumed here, x will be produced here, x will be produced here. It means at equilibrium, the concentrations will be initial minus initial and final. So consumed here, so it will be 0.78 minus 2x. This will be initially 0, x produced, x only, x only. Any confusion? Anyone? Okay, fine. So if there is no confusion, write the value of Kc and substitute it, get the answer, get the value of x. Equilibrium concentrations have been asked. When you get the value of x, substitute it here, here, and here, that will be the answer. When you substitute, obviously, iodine and chlorine will be same concentration, both are x, so both will be same, 0.167, 0.167. It will be 0.78 minus 2 times 0.167. 0.78 minus 2 times x, that is 0.167, you will get 0.4467. Next, and this one is important. Okay? This one is slightly different, so that's why it is important. And if you don't do it before your exam, means right now, for example, it will be difficult to get it in the examination. Ethyl acetate is formed by the reaction. So this reaction is given, and here ethyl acetate is being formed. Till now, what we have done, if you remember, we have done reverse of it. Means we started from here, and these were the products. So in class, that's what we have done. But here it is reverse reaction. From acetic acid and ethyl alcohol, we are getting ethyl acetate and water here. In this case, remember, you can't ignore the concentration of water. Here it is, that's why written. Note, water is not in excess and is not a solvent in this reaction. If you have reaction in this side, you are starting with water. So you had some water and then say this much water remained. then you can say, yes, concentration remained constant. Now tell me, this is a question for you, and you will tell me, if you start from here, CH3COOH liquid plus C2H5OH liquid, if you start from here, did you have any water? So can you say water's concentration remains constant? My question. You initially did not have any water. So you can't say water's concentration is constant throughout the reaction, which is pure liquid. Clear or not what I am saying? My question is clear or not? Okay. Am I audible clearly?
Yes, sir.
Yes, sir.
So in such cases, where water is not solvent, it is rather on the product side, or it is written it is not in excess. If it is not in excess, its concentration is not considered as constant. Means it has been produced here. There initially the concentration was 0, and then there will be some concentration. So we won't say the concentration is constant. In such cases, this will be included in equilibrium constant. So when you write the equilibrium for this one, you will include water's concentration as well. Is the reason clear what I am saying here?
Yes.
Okay. So write the concentration ratio reaction quotient, that is QC, for this reaction. So you will include everything. So QC will be CH3COOC2H5 H2O. These are the products, divided by CH3COOH and C2H5H. Anyone? Any question you need to ask? Okay. It is clear. So this is how you will write. Okay. You will include H2O. Then second one is for the same question, at 293 Kelvin, if one starts with 1 mole of acetic acid and 0.18 mole of ethanol, there is 0.171 mole of ethyl acetate in the final equilibrium mixture. Calculate the equilibrium constant. So QC we had calculated in previous case. What will be the equilibrium constant here? The trick here is that you will include this one as you did in case of QC. You will include this one also in case of KC. But the problem is, how do you get the concentration of H2O? It is not given. That is very easy to calculate. It is given that we start with 1 mole of acetic acid. So this is 1 mole. 0.18 mole of ethanol. 0.18 mole of ethanol. Okay. There is 0.171 mole of ethyl acetate in final equilibrium. So initially, obviously, these were 0. At final equilibrium, what happened? So this is initially. And at equilibrium, it will be 1 minus x, 0.18 minus x. It is 1:1 ratio, remember. Okay. This is 1 mole. This is also 1 mole. This is also 1 mole. This is also 1 mole. So all 1 mole. Okay. So if x moles consumed here, x moles will be produced. So it means if at equilibrium 0.171 mole of ethyl acetate, that is this one is there, same number of moles will be of H2O because we have 1:1 ratio. Clear? So it means I will say at equilibrium, I will have 0.171 mole of ethyl acetate and 0.171 mole of water. And here, because x is 0.171, I will write 0.171 here, 0.171 mole here. It means this is 1:1:1:1 ratio. So whatever is consumed, same amount will be produced. Anything not clear? So you have equilibrium concentrations. Calculate equilibrium constant. Equilibrium constant will be same formula what we had done in previous case. Okay, this one same formula. Now we will call it Kc. Substitute the concentrations. Get the answer. When you solve it, you will get 3.92. These concentrations you will substitute. Third part of the same question is starting with 0.5 mole of ethanol and 0.1 mole of acetic acid and maintaining it at 293 Kelvin. So let me see previous question. Consider that acetic acid and ethanol. Yeah, correct. Starting with 0.5 mole of ethanol and 1 mole of acetic acid and maintaining it at 293 Kelvin, 0.214 mole of ethyl acetate is found after some time. Has equilibrium been reached? Now you will consider it as QC. It means we may or may not be at equilibrium. If QC comes out to be Kc, we will say yes, it is at equilibrium. Otherwise, so what is the case here? 0.5 mole of ethanol and 1 mole of acetic acid we start. Okay. So ethanol is 0.5 mole and 1 mole acetic acid. And initially, obviously, these were 0. So 1 minus x, 0.5 minus x, and we have 0.214 mole of ethyl acetate. Same will be water. Okay. So because here it is 0.214, it is 1:1. This x is 0.1. Here also x is 0.21. So you have
So what was the answer of the previous question? What was the answer of the previous question?
3.92.
Okay.
So again, you got the concentrations, but it will be QC now. Calculate QC from here, which will obviously be CH3COOC2H5 concentration, product concentration, divided by reactant concentration raised to their stoichiometric coefficients. It will be 0.214 into 0.214 divided by 1 minus 0.214. So it will be 0.786 into 4.786. Substitute these values. It is not 5, okay, sorry, it is 0.5 minus. I considered it 5. It will not be 0.4 point, rather 0.5 minus 0.14 is 0.2. 0.286 it will be. So from here you will calculate the value of QC. Okay. One important point which you should consider, okay, but one important point about this, okay, which I missed. Here moles are given. I just noticed here moles are given, so you can't consider these as the concentrations. So instead of writing 1, you should write 1 divided by some volume. Okay, so you will say 1 divided by V, 0.5 by V. Here also divided by V, divided by V, divided by V, divided by V. So obviously these V will get cancelled. In this case, V will get cancelled, but you have to write it. Okay, so divided by V, divided by V, because we can't consider number of moles. Here we have to consider concentrations. All these V's will get cancelled. Let me see if I have the answer. Okay, QC you will get 0.204. 0.204. And KC we had calculated probably in the previous question. Here it is not given. Remember, Kc will not change. Whether you change the concentration or not, Kc will remain same. So Kc was 3.9. Yes, correct. 3.92. So this was the value of Kc. We will compare it. So Qc we got 0.204, which is obviously less than 3.92. So it means the equilibrium has not been reached. Okay. If Qc is greater than Kc, then you will say it is beyond the equilibrium. Remember, the question here was, has equilibrium been reached? So we are writing in that sense, yes, Qc is less than Kc. We are writing same thing. Equilibrium has not been reached. If Qc would have been equal to Kc, we will say equilibrium has been reached. If Qc is greater than Kc, then we will say it is beyond the equilibrium. In this case, no, it has not been reached. Next question. One of the reactions that takes place in producing steel, this reaction is given. You don't need to go into details. Kp is given for this reaction. What are the equilibrium partial pressures? Means you have to calculate the equilibrium composition. Whether it is asked equilibrium partial pressure or equilibrium composition, it is same thing here, because we are talking about Kp, concentrations are in terms of partial pressures. Again, you need to do in a similar fashion. Okay, it is given that initial partial pressures are these ones. Initial partial pressures are given. So what you do? If we are talking about in terms of partial pressure, tell me whether there will be any contribution from iron, solid iron oxide and iron solid here. No. Okay. There won't be any contribution from these. So what you will say? You will say initially the partial pressure of carbon monoxide is 1.4 initially, and of carbon dioxide 0.80. Obviously, you are not going to consider partial pressures of these one. You can say 0 if you want. You can say 0. Okay. It will remain 0. So you don't need to even mention that. 1.4 atm. And here also atm. It means we can calculate whether it is, and it is very important question. Okay, what I am going to say, it is very, very important question. In this case, both reactant and product concentrations are given. So just repeat it to yourself, write it 2 times. Students make a mistake here that they consider that reaction should be going in forward direction. No, because we have concentrations of both, reaction can be at this point of time going in backward direction also. So in this case, you will first calculate, you will first find whether reaction is going in forward direction or backward direction. How do you do that? Calculate QC. What is QC? So with these concentrations, these are the initial concentration. I will calculate whether I am before the equilibrium here or I am beyond the equilibrium on the right hand side. So QC here will be partial pressure of CO2 divided by partial pressure of carbon monoxide. Here we have 1 mole, so to the power 1. Here we have 1 mole to the power 1. Solids will not be considered. So it will actually be 0.80 divided by 1.4. which will give you 14.570. Then 7. Yeah. Approximately 0.57 it will be. Okay. 2 will be there. You can write 120. And Kp is given 0.265. Kp is given 0.65. And here you will call it Q, not QC, Q, because we are using partial pressure. So it means Qp is greater than Kp. So tell me in which direction the reaction is going at this point of time. If Qp is greater than Kp, in which direction?
Backward.
Yes. So it means the reaction is not going in forward direction. Reaction is actually going in backward direction. And that's how you need to do the calculations now. So your calculations means how much is consumed. Consumption will actually be on right hand side now, and production will be on left hand side. Okay, so after this you will say as QP is greater than KP, reaction is Fe solid plus CO2 gaseous FeO solid, carbon monoxide gaseous, and here Kp dash will be 1 by Kp, that is 1 by 0.265 per ATM. Okay, per ATM. Here it is ATM. Now the unit will also change per ATM. Up to here, any confusion? This is very important part of these type of questions. Okay. So also note down question number 20. Anyway, you have to do one more question. I told you, I think that was question number 15, probably, that you have to do 2 times. This one is also you have to do. These type of questions are very important. And where you need to just have an alarm, where you have concentration of both. So concentration of reactant as well as products are given. In that case, you have to check whether the reaction is going in forward or backward direction. So now the question is, this reaction Kp is also known. So what are the concentration? Now you will say, okay, initially I have 0.80 atm of CO2 and CO is 1.4. Now suppose change is P. So 1:1 ratio is, so at equilibrium, this is initial. And just let me see, just wait. Let me see whether I'm connected to fast connection. Just a problem. Okay. So initially this is the case. Then at equilibrium, what will happen? Suppose there is decrease of pressure P here. There will be increase of pressure P here. 1:1 ratio. 1 mole of carbon dioxide on left hand side, 1 mole of carbon monoxide on right hand side. 1:1 ratio. So whatever is consumed, that much will be produced. And you know Kp dash for this one. So what will be Kp dash? You will say Kp dash is carbon monoxide partial pressure divided by carbon dioxide partial pressure, product partial pressure divided by reactants partial pressure, raised to their stoichiometric coefficient, which is 1. And you know everything. You know Kp for this reaction is this much. Partial pressure of equilibrium partial pressure of carbon monoxide is 1.4 plus P. Equilibrium partial pressure of carbon dioxide is 0.80 minus. Substitute these values, get the answer, get the value of P. Is that clear or not, everyone? Any confusion here specifically? Okay, Sayak, fine, good. My question is to Shambhavi. Is that clear or not? Confirm.
Yes, sir.
Rohan Dabral, clear or
Yes,
not?
sir.
Okay, so I am correct. Good. So that's how you will get the value of P. And once you get the value of P, you can get the partial pressures, equilibrium partial pressures. Substitute those values here. These are the equilibrium partial pressures, 0.80 minus P and 1.4 plus P. These will be the answers. Once you substitute the value of P, you will get equilibrium partial pressures. Next one, equilibrium constant Kc is given for this reaction. At a particular time, the analysis shows that composition of the reaction mixture is this much. Okay, concentration. Is the reaction at equilibrium? Again, the same thing. Okay, you will calculate QC with this one, and you know what is QC, how to calculate that. Compare it with KC. If QC is less than KC, it is in forward direction. If QC is greater than KC, it is in forward direction. In this case, it will be the reaction will proceed in forward direction. You will get QC less than KC. Next one. At this temperature and 1 atm pressure, a gaseous mixture of carbon monoxide and carbon dioxide in equilibrium with solid carbon has 90.55% of carbon monoxide by mass. So by now, I think you should be clear what we mean by 90.55% CO by mass. Can anyone tell me? Who will tell me what it is telling us here? Yes, Ashmai. Yes, Ashmai, correct. I am expecting answer from other students as well. What is this 90.55%? Tulika, yes, we can use it in that sense. Okay, fine. Now, when it is given here, 90.55% CO by mass, it means we can assume it is 100% total. We can assume that it is 100% total, but not including solid carbon, only the gaseous forms. So try to understand what I am saying here. Okay. In the question, it is written, it is a gaseous mixture of this one, carbon monoxide and carbon dioxide. So mixture is, we are talking about carbon monoxide and carbon dioxide. And we will assume that this mixture is 100%. In that case, if it is 100 gram, so we will say assuming the mixture of CO and CO2 is 100 gram. Then mass of carbon monoxide 90.55 gram, mass of carbon dioxide 100 minus 90.55, 9.45 grams. From here, you can calculate moles, right or not?
Yes, sir.
Okay. So remember the trick here is, it has been mentioned this in this gaseous mixture, carbon monoxide is 90.55. It means you have to exclude this one. This is not included in this gaseous mixture. In gaseous mixture, carbon monoxide is 90.55%. It means carbon dioxide will be remaining. So this is where students make mistake. Instead of gaseous mixture, they consider the entire mixture. Our question is talking about only gaseous mixture. So from here, you can get number of moles of carbon monoxide and number of moles of carbon dioxide as well. Carbon monoxide, it will be given mass divided by its molar mass. Molar mass will be carbon 12, oxygen 16, that is 28. Here it will be 9.45 divided by molar mass of carbon dioxide, 40. Then you will, how do you get, okay, what is asked? Just calculate the Kc for this reaction at the above temperature. Okay. So for that, it means now you need the molar concentration, or you can calculate the, okay, it is given 1 atm pressure. Okay, it means first you will have to calculate Kp, and from Kp, you will get Kc. So understand this question is even trickier than, okay. what you can think of. Here we are talking about that at some pressure, temperature and at some pressure, these are the concentrations, means percentage wise, means this will have the pressure not in proportion to the mass, rather in proportion to the moles. Because here number of moles will have same number of molecules, same mass will not have same number of molecules. So same mass will not have same molecules, but same moles will have same molecules. So that's why to calculate the pressure, you will have to convert it into moles. That's why you converted these two moles. Now you need to find out these moles will produce how much pressure here, partial pressure, so that you can calculate Kp. And from Kp, you will be able to calculate Kc. Okay. So how do you calculate Kp? Sorry, partial pressure. This is something we have done in one question earlier also. This is the pressure, total pressure, 180. And suppose here I get something, here I get something. Suppose I get X here and Y here. Then what will be the partial pressure created by X mole? It will be how much fraction this is of total multiplied by total pressure. That is this pressure divided by total pressure. That is this moles, sorry, not pressure. These many moles divided by total number of moles into total pressure. So understand it again, if you're not able to get it, what I'm saying. Partial pressure will be, and remember, if you try to understand it yourself, it's gonna take 3-4 times more time. And even then you can make mistakes. So partial pressure will be, what is the total pressure and what is the fraction of the component I am talking. Means fraction of carbon monoxide will give multiplied with total pressure will give you pressure created by this carbon monoxide. Fraction of carbon dioxide multiplied with total pressure will give you partial pressure created by carbon dioxide. So what is this fraction? This fraction is of these moles. So it means we need to get mole fraction here. So write this formula. Partial pressure is given by mole fraction multiplied by total pressure. Pressure. This formula you will be using. Here you are using it first time. In 12th, you will be using it multiple times. Better you remember this formula. Partial pressure is total pressure multiplied by its fraction. That is mole fraction. Mole fraction multiplied by total pressure. So it means first you need to calculate mole fraction. And if I have X moles of CO and Y moles of CO2, from your mole concept knowledge, can you tell me what will be the mole fraction of CO? Who will tell me what will be the mole fraction of CO, carbon monoxide, if I have X moles of CO and Y moles of CO? I want to know how many of you can recall. Write it in chat box. Okay, don't tell me. Write it in the chat box. The mole fraction of CO. You have X moles of CO and Y moles of CO. Tulika, no. Sudhit, yes, good. For simplicity, I'm just telling you use X and Y. Okay, that's why I have written XY so that you can write it easily in the chat box. If you have X moles of carbon monoxide, Y moles of carbon dioxide, what will be the mole fraction of carbon monoxide? Rida, yes, correct. Okay, give me answer in terms of X and Y instead of writing too much. So Sudhit and Rida have given me correct answer. Anyone else? Mole fraction is number of moles of whatever we are talking about divided by total number of moles. We are correct. Okay. Yes, Bhavya. So mole fraction of carbon monoxide will be its moles divided by total number of moles. Okay. And if we have only two components, the other one will obviously be 1 minus number of moles of first one. So you can say, if you want to calculate, you can say number of moles of CO2 will be its moles divided by total number of moles. So it will be y divided by x plus y. But y divided by x plus y is sum of all fractions is always 1. This is something you know from your previous grades. 1 minus mole fraction of carbon monoxide. So you will get mole fractions. Once you get mole fractions, you will use the formula. Substitute these mole fractions here. Total pressure is 1 atm. It is given. So you will get the partial pressures. Now there is nothing. You get the partial pressures. Substitute in Kp. Kp for this section will be how much? Kp will be product concentration, that is partial pressure of carbon monoxide, which you have calculated this formula, whole square because it is 2 divided by partial pressure of CO. Solid will not be considered. So substitute, get Kp. After that, remember Kc has been asked. Then you will apply your usual formula Kp equals to Kc RT to the power delta Ng. Delta Ng will be here 2 minus 1. Product moles gaseous 2 and 1. And you will not consider solid again. So delta Ng will be 1. R you will substitute 10.0821 because we are talking in terms of ATM. So in terms of ATM, R will be 0.0821. Temperature is given 1127. Substitute that value. Get the case. So slightly lengthy question. You need to understand all these points. So just try to recall the steps. What we have done here, how we have calculated. Before I move to next question. In many questions, it is something I have explained in the beginning also when we started the session, the mole concept, we started that chapter, that if you are confused in numericals, specifically in mole concept, thermodynamics, and equilibrium, first you need to draw the path. So write what you need. After that, what you need to get that, so that you get the initial state from where you need to start. So in this case, how will you prepare the path? Okay, so you have to get Kc. You cannot get Kc directly because no concentration is given. Concentration is given in terms of pressure. So it means you can get Kp first. You cannot get Kc. Moles are not given. Only ATM is given. Okay. There is another way also. Okay, I will tell you another method also. You will get same answer, and few students find that method suitable. Although that method I have not seen anywhere in guide, etc. But that's not wrong method. That is good method. Okay. I will tell you. So first understand the path. How will you form? So you can get Kc from Kp. You will write it like this. And Kp, what you need for Kp? For Kp, you need partial pressures of CO and partial pressure of CO2. This is what you need. Okay. You can't get partial pressures unless here, in this case, from total pressure. Have total pressure. Can get partial pressure only if you have mole fraction of CO and mole fraction of CO. Then you can get, because you will use partial pressure will be equal to mole fraction into total pressure by using this one. Okay. For mole fraction, you need moles. And for moles, you need masses. And mass you can get from percentage. So this is the path. From percentage, you will get the mass of each. From mass, you will get moles divided by molar mass. Then from moles, you will get mole fractions. From mole fractions, you will get partial pressures by using this formula. From partial pressures, you will get Kp for this one, partial pressure of CO whole square divided by partial pressure of CO2 by using this one. Okay. Then from Kp to Kc, you will use Kp equals to Kc RT to the power delta Ng. Any confusion? So write this path and learn to draw these flow charts, how the flow of the question will be there to get the answer. Write it down. Right. Now, if you want, you can try the other method also. In that case, what is the, I hope everyone has noted down the flow.
Yes, sir.
Okay. What you can do, you can use the formula PV equals to.
Sir, can you
NR.
take to the previous slide? For a
No, I
second, sir.
can't because I have erased everything. That's why I asked. Okay. So PV equals to nRT. From here, you will have PV P equals to N by V, and I have told you N by V is actually concentration, RT. So you can get concentration from here. So it means instead of using ATM pressure, you can say the concentration, total concentration of these ones is this much, what you have to. And then you can do the percentage wise, that concentration of CO will be how much, concentration of CO2 will be how much, depending on the number of moles. And then you can get directly Kc in that case. Okay. So you can try that way also. But usually why I say that you should not be doing it, because this is not mentioned anywhere and your teachers normally follow the previous approach, what I have explained. So normally in 11th, your teachers are very much strict, or I can say adamant type. They follow the methods which are popular. So once you solve, you will get 0.153. Next one. Does the number of moles of reaction products increase, decrease, or remain same when each of the following equilibria is subjected to a decrease in pressure? Okay. By increasing the volume. So you are increasing the volume and decreasing the pressure. So do you remember, first try to recall what we talked about when we changed the pressure, volume changes here. Okay, volume is not constant. So what will happen? Remember, I am not talking, some students get confused here with the injection of inert gas. Okay, so this is not inert gas injection. There, it is different concept. If, for example, we have balloon and we inject inert gas, the volume will increase. Okay, then it will impact the equilibrium. Otherwise, in that case, inert gas won't have any impact. Here I am talking about only the pressure change. Means we have increased the volume, pressure has decreased. So answer is very easy, which you usually do. Okay, so this is the normal case. When you decrease the pressure, volume has to be increased. That case, okay, volume will increase. PV equals to nRT we are applying here. So you can tell me the answer very easily. The equilibrium will go in that direction where you have greater number of moles. Why? Because the equilibrium, the reaction will try to increase the pressure. If you decrease the pressure, equilibrium will be reached by increasing the pressure. It means the reaction will go in that direction where you have greater number of moles, higher number of moles, because greater number of molecules will create greater pressure. So in this case, the reaction should go in this direction. Okay, means it will increase. The number of moles of reaction products will increase. The question is, number of moles of reaction products will increase, decrease, or remain same. In this case, it will increase because it will go in forward direction. Any confusion here? Anyone? Rohan, is that clear?
Yes, sir.
Correct. Now, next one. You have here solid, solid. You have only CO2 on left hand side, which is gaseous. Now, suppose you decrease the pressure. If you decrease the pressure, the reaction will try to increase the pressure by increasing the number of moles. So in which direction it will go? Whether the product's concentration will increase or decrease? Write your answer. Everyone write your answer. Don't just sit back. Rida, correct? No, Rohan, no, Ashmai. Remember, I am saying decrease in pressure. Pay attention. It's very, very easy thing what we are talking about. Okay. Pressure decreased. When pressure decreased, system will try to increase the pressure. How? By increasing the number of moles. So it means it will go in that direction where you have greater number of gaseous moles. On left hand side, you have 1 mole. On right hand side, you have 0 moles. So it means it will go in backward direction. It will go in that direction where you have greater number of moles so that the pressure could be increased. So the products here will decrease. CaCO3 will decrease because reaction will go in backward direction. Pranit, is that correct? Priyas, is that correct or not?
Yes, sir.
So it's
Yes, sir.
one, there should not be any mistake. No chance of mistake here. Next one. This is something I will ask you. You will tell me, everyone. In this case, what will happen? The reaction products concentration will increase, decrease, or will remain same? Rida, correct? Everyone, you have to answer. Tulika, no. Rohan, yes, correct. Pranit, correct. Shambhavi, no. Bhavya, correct. Swayam, Sayak, Anirudh, Sudhit, Vanshika, Vansh. Prayas, no. These solids will not be considered. You are considering solid. That's why you are giving me wrong answer. And then you have only 4 moles on both sides. 4 moles on left hand side, 4 moles on right hand side, gaseous. Only gaseous will be affected by pressure, not solid or liquid. So if you have same number of moles on both sides, reaction will not get disturbed by pressure. So equilibrium will not get affected. So it will remain same. Okay. Next one. Which of the following reactions will get affected by increasing the pressure? Also mention whether change will cause the reaction to go into forward or backward direction. Again, that's very similar question, but here we are increasing the pressure, not decreasing. In previous case, we were decreasing, here we are increasing. So if we are increasing the pressure, system will try to system will try to reduce pressure. How it will try to reduce pressure? By reducing the number of moles. It means the reaction will go in that direction where it has fewer number of moles, less number of moles. So this is something you need to first write, that I will see that direction where gaseous moles are less than the other side. So less we are focusing. This question. Here you have 1 mole and here you have 1 plus 1. So it will go in backward direction. So first you will write, because the question is talking about first which of the following reaction will get affected. So you will say yes, it will get affected. Okay, it will get affected and the reaction will go in backward direction where it has less number of moles. That is something we have already talked about. Okay, why in less number of moles? Here again, all are gaseous. You have 1 plus 2 moles. Here you have 1 plus 2 moles. Means no effect. It will not get affected. You have same number of moles on both sides and all are gaseous. So no change. Then you have this one. This one is solid. You will not consider it. So first you will strike off, not on paper, just a strike off in your mind that this is not to be considered. Then you have 1 mole and 2 moles. It means backward direction, fewer number of moles, because you are increasing the pressure. It will go in that direction where you have less number of moles, backward. Then this one here, all are gaseous, fine. 1, 1. Here you have 3, so it will go in back forward direction where you have less number. Then this one is solid, you will not consider. This one is solid, you will not consider. Only this one is 1. Here you have 0, so obviously it will go in backward direction. Less number of moles, 0. Gaseous moles only you will consider. This one, all are gaseous, you don't need to bother. 4, 5, 4, 6. Here you have 9, here you have 10. It means it will go in backward direction. Next, the equilibrium constant for this reaction is given. Okay, equilibrium constant is given. Find the equilibrium pressure of all gases if 10 bar of HBr is introduced into a sealed container at the same temperature, 1024. So 1024 was the temperature earlier also. Now also temperature is not changing, so you can use the same concentrations. Easy one. Might be one point I need to explain, but otherwise it is easy one. Just see whether you can do it yourself or not. Okay. Now, what the point I need to explain here, basically, the only point, basically. Otherwise, it's very easy. What is this 1.6 into 10 power 5? It is written equilibrium constant for this reaction is 1.6 into 10 to the power 5. Whether it is Kp, Kc, what is it? And how do you find it? Okay, so I am fine. Okay. Basically, it is both. It is both. Kp and Kc in this case will be equal. The reason is you have 2 gaseous moles here, 2 gaseous moles here. Delta Ng is 0. If delta Ng is 0, Kp is equal to Kc, RT to the power 0, and anything to the power 0 is 1. It means Kp is equal to Kc. So you will use it as Kp because we are talking in terms of pressures. That is the only point you need to understand. Is still not clear? Let me know. Okay. And remember, it is very important that you attend these sessions, practice sessions. If you try to do these questions yourself, you will get stuck. And then you will leave it. And certainly you will not be able to do in examination. These simple points you need to understand. It is Kp or Kc, both. Now it is very easy. You will say H2 plus Br2 2 HBr. Okay, and you have 10 bar of HBr. Okay, so we will write it in reverse direction, right? Because find the equilibrium pressure of all gases if this not Br is introduced. So it is opposite. So we will write reverse reaction. 2 HBr gives us H2 and Br. And initially we started with 10 bar. Here we had 0, 0. And suppose the change is minus 2p. Why I'm saying 2p? Because here it is 2 written. So I'm saying minus 2p. Here it is 1. Is P introduced here, P introduced here. On the right hand side, it is produced, that was positive, here consumed, that's why negative. So it means at equilibrium, how much amount will be there? 10 minus. Out of 10, 2P got consumed. These are equilibrium concentrations. And you know Kp for this one will be 1 by, say it is Kp dash, 1 by Kp. That is 1 divided by 1.6 into 10 to the power 5. So now write Kp dash equals to will be what? Partial pressure of H2 multiplied with partial pressure of Br2 divided by partial pressure of HBr whole square. Here whole square why? Because here. That's why. Equate it to Kp dash. Kp dash is 1.6 into 10 to the power 5. Okay. Substitute these values. PH2 is P. Partial pressure of Br2 is P. Partial pressure of HBr at equilibrium is 10 minus P whole square. Okay. Form the quadratic equation, get the value of P. Once you get the value of P, substitute those values here. You will get equilibrium concentrations. What is asked? Find the equilibrium pressure of all gases. That is asked, equilibrium pressure of all gases. So if you get the value of P, the same P will be partial pressure of H2 and Br2. 10 minus 2P will be partial pressure of HBr. Okay. So once you solve it, you will get these partial pressures of H2 and Br to 2.48 into 10 power minus 2 and partial pressure of HBr as 10 bar. Now, one point, understand. Initially, it was 10 bar. And here also, I am saying it is 10 bar. Why? The reason is because this value is very, very small. 2.48 into 10 to the power minus 2. So approximately, if you calculate this value, 10 minus partial pressure of HBr will be 10 minus 2P. And P we have calculated as per the answer here 0.0248. P is 2.48 into 10 power minus 2, that is 0.0248. So if you do 10 minus 0.0456, no, 86, 96. So this is approximately 10. So that's why it is written 10 bar. If you want to write 9.051, etc., that is fine. Any question here, anyone? Anything not clear? Bhavya, is that clear? Bhavya and Ishita?
Yes, sir.
Yes.
Okay. Shambhavi, is that clear?
Yes, sir.
Okay, fine. So I'm stopping here now. We have done till question number 27. Rest we will do later on. Keep revising. Take care. Have a good day. Bye-bye.
Good afternoon, sir.
Thank you, sir.
Thank you, sir. Bye, sir.
Bye.